Hi folks, this is Calc 2 Quiz 8. We're asked to determine if the given series converges or diverges and state which test you use and all the relevant details. So here's letter A. So what's going on here? We got this rational type or fractional kind of series. So let's look at what I can get from this. If I look at the highest power in the numerator, it's going to be that 2n piece. The highest power in the denominator is going to be the square root of n to the fourth. And that's the same as the series n equals 1 to infinity, 2n over n squared, which is the same as the series n equals 1 to infinity, 2 over n. And what do we know about this character? Well, it's a p-series. P equals 1, which is less than or equal to 1, which means it diverges. So our gut tells us that this series, even though it looks more complicated, as n goes to infinity, these terms are going to look an awful lot like these terms. And since this series diverges, this is going to also. So the tool of choice here is the limit comparison test. So I'm going to take the limit as n traipses off to infinity of the terms of this series divided by the terms of this series. And since we have two fractions here, I'm just going to take the first one and multiply it by the reciprocal of the second one. So that's the limit as n traipses off to infinity. I have 2n squared plus n over 2 times the square root of n to the fourth plus 1. So we take a trip back to Calc 1. How do we handle these kinds of animals? We'll factor out the highest power in the numerator, which is n squared. We're left with 2 plus 1 over n, divided by the highest power in the denominator. I'll take an n to the fourth out underneath the radical, but that n to the fourth comes out as an n squared. So these n squareds cancel each other out. And I'm left with the limit as n goes to infinity of 2 plus 1 over n divided by the square root of 1 plus 1 over n to the fourth. As n traipses off to infinity, the 1 over n goes to 0. 1 over n to the fourth goes to 0. I forgot my 2, which is still in there. And so I get 2 over 2, which is 1. Now what's important about 1? Since 1 is a finite positive number, by the LCT, since the series n equals 1 to infinity of 2 over n diverges, so does the given series. So that'll do it for part A. Let's look at part B. Given the series n equals 0 to infinity of 1187 to the n power over n factorial, the first thing I key in on is n factorial. And I'm as excited as the exclamation point suggests I would be, because as soon as I see factorials, I think ratio test. So for a ratio test, I look at the limit as n traipses off to infinity of the absolute value, an plus 1 over an. And once again, since we have fractions involved, I'm going to take an plus 1 and multiply it by the reciprocal of an. Absolute values here aren't needed because everything in sight is going to be positive. So I get 1187 to the n plus 1 over n plus 1 factorial times n factorial over 1187 to the n. Limit as n goes to infinity. Let's get the 1187s together. And the factorials together. So this is the limit as n traipses off to infinity. 1187 to the n plus 1 over 1187 to the n. You subtract the exponents, you just get 1187. n over n plus 1 factorial just gives you the n plus 1. Remember, with these factorials, when in doubt, write them out. You've got n times n minus 1 all the way down to 1. Here you have n plus 1 times n minus 1 all the way down to 1. So everything cancels except that first one there. And this is 0. And what's important about 0? Since 0 is less than 1, our original series converges by the ratio test. And so, folks, that'll do it for Part B, and that'll actually do it for Quiz 8.